Alright, so in this video what I'm going to do is I'm going to give you an example of how to identify the circle equation given the center and radius, the center and a point on the circle, and if you're just given the graph. So the first thing we're going to do is, what if we're given the center and the radius? So this one is the most straightforward. We're always looking for the center and the radius whenever we're trying to identify the equation of the circle. So just as a refresher, the standard equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. And so I want to identify my h and my k and then my r. So in my center, the point is just comprised of our h and our k. So the x value is at h, y is at k, and then radius is r. So that one should be pretty easy to remember, radius r. So we've got, all I'm going to do is I'm just going to plug in what I know, and then that's pretty much it. I've got x. Now remember, whenever you're dealing with identifying the equation, you are just going to flip the signs of each of your h and k's. So if I have an h value of positive 16, inside the equation it is going to be x minus 16 quantity squared. And then y, if my k is negative 3, is going to become y plus 3 quantity squared. Because in the standard form, just a standard form written out with our h and k, you're subtracting. So you need to flip the signs when you put an actual value in there. So I've got x minus 16 quantity squared plus y plus 3 quantity squared equals r is 3, so r squared is 9. Okay? So that's if you're given the center and the radius. What happens if you're given the center and a point on the circle? So let's just envision this. I've got a circle, I've got the center, and I've got a point on that circle. Remember, the two things that we need in order to create our equation is we need the center, which we got that right here, check mark. And now we need the radius, but we don't have the radius. We've got a point on the circle. Well, if we were to find the distance between these 2 points, we'd be able to find the radius, right? Because the radius is just the distance between the center and a point on the circle. So I'm going to try and find the radius using the distance formula. So I'm going to have, this is x1 and y1. This is x2, y2. And so I'm going to have 10 minus 13 squared plus 5 minus 0. 5 minus 0 squared. Okay? And so I'm going to have negative 3 squared plus 5 squared. So my radius is going to be 9, square root of 9 plus 25, or just simply square root of 34. So my radius is square root of 34, and you can simplify even further by maybe pulling out a perfect square. I like to leave it as just this right here, and the reason is because whenever you put it into equation form, it's going to make it really nice and simple. And so now I've got my radius, I've got my center, and now I just do the same exact process as I did before. So I've got x minus 13, see up here I got 13, so x minus 13 squared plus, well, our k is 0. So instead of writing y minus 0 quantity squared, we can just write y squared. And then last but not least, r squared. Well, if r is square root of 34, then we're going to have just 34 here. Because if you square a square root, the radical goes away. Oh, I'm sorry. The radical goes away, and we are just left with what is inside, also known as the radicand. So my final equation is x minus 13 quantity squared plus y squared equals 34. And then the last one is try and write the equation if you're just given a graph. So again, we need to find the center. Whoops. And I need to find the radius. Okay, so the center, just find the center of the circle, plot a point, see where the coordinates are. So this one we've got negative 4 through negative 3. So that's my center, and then my radius is 1, 2, 3. So always be careful of the center, okay, the radius. This radius length is 3. Don't go all the way over here. So my equation is going to be x plus 4 squared plus y plus 3 squared equals 9. And those are the 3 ways that you can be given this information.